Hi students, in this video we're going to do logarithmic functions. I'll be providing you with a complete and effective revision guide on how we can apply the concepts of the logarithmic laws. We'll be doing practice questions, right? So please stay till the end. Right, so first of all we need to understand the definitions of the logarithmic functions. So let's start off by understanding how log y base a is defined. Right, so first of all, there are certain conditions that need to fulfill. If you look at the screen, right, this refers to the base of the log functions, and the base has to be more than 0, and it cannot be equals to 1. Another condition is this value here, the y value, has to be positive, more than 0. Right, and there are two different types of log. One is the common log, where you can actually find it in most calculator, and that is log base 10. So in the textbook or in the exam questions, right, you will, if you were to see LGA, it means it's log base 10. Right, another thing to take a note is that it's also another special base for the log, and that is base E. And usually it will appear as Ln in the exam, test, or in the textbook. So Ln actually represent log base E. Right, so these are the three basic concepts. 1, 2, 3, 4, 4 basic concepts that you have to take note. Right, so how can you actually apply these concepts in an exam questions? Let's take a look. Right, so the questions could be such that you're given some logarithmic functions, and you asked to find the range of values of x for which the following expressions, whether they are being defined, meaning whether they fulfill the earlier conditions that we have recapped on the definitions of the logarithmic functions or expressions. So let's look at A. Right, so basically you just compare what you're given with log y base A. Right, so you will see that the values of A is 4 here, and 4 is a value that's more than 0 and is not equals to 1. So we satisfy this condition here, right? And then the next thing is we compare this value, x minus 8, with y, and we, from this first condition here, the values of y has to be more than 0. So therefore, my x minus 8 has to be more than 0. So hence, for these functions to be defined, the values of x must be 9, 10, 11, 12, so on and so forth. Right, if there's anything less than 8, let's say, for example, a 7, if you were to substitute into the functions, you end up getting -1, which is not defined. Alright, so this is how we can apply the concepts we've just explained to solve problem sums. Right, so let's look at part B. Alright, likewise, Ln is log base E, and if you look at the calculator, base E, it's 2.718 estimated to 4 significant figure, and definitely 2.718 is more than 0, it is not equals to 1. So it satisfies these conditions again, right? And the values of y has to be more than 0. Therefore, 4 plus x here, this one has to be more than 0, therefore the values of x has to be more than negative 4 for this particular expressions to be defined. Okay, so far so good. Right. Probably you can try part C and D on your own, and then I'll go through it with you. So you can pause the video here, try C on your own. Right, I'll show you the answer. Right, so likewise, LG is log base 10. Right, so the base is 10, more than 0, not equals to 1. So again, satisfy this condition. And my 3 minus x must be more than 0. So therefore, alright, so take note here. Okay, take note here. This is a special, what do you call that, properties of an inequality. If you're going to multiply both sides with a negative number, right, remember to flip your inequality sign. Alright, so for this particular functions to be defined, okay, your values of x must be less than 3. Right, so you may want to pause the video again to try to do part D before you look at the answer. Okay, here we are. Right, part D is slightly more challenging. Why more challenging? Because if you were to look at what you're given as the base, it's an unknown value. Okay, it's different from part ABC where you are told the values of the base. Here you're not told. Okay, but we know that for it to be defined, the base x has to be more than 0 and not equals to 1. So therefore, we must have these two conditions first, right? And then the second condition is this guy here, this has to be more than 0. Okay, and be careful to multiply. When you multiply both sides with a negative number, be careful to flip the inequality sign. So I would have to combine these conditions with these conditions. Need to combine them. So combining these two conditions, what do you think the inequality will look like? Yes, it will have to be more than 0, less than 3, and we need to specify that x cannot be equals to 1. Alright, so this is how we can apply concept 1. Okay, so another very important concept that we have to take note is the conversions from the index form to the logarithmic form, and also from the logarithmic form to the index form. Okay, very important for solving exponential equations, also for solving logarithmic equations. All right. So I'm just going to give you some examples on how we can do it. So supposing I have e to the power x, let's say, equals to 3. Okay, so this is index form, right? So I need to change this to the logarithmic form. Right, so what we need to do is recognize the base first. So if you look at it, the base is your base e. Right, so base e is log base e. Do you remember what is the symbol for log base e? Yes, very good. I heard you. It's ln. 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 So ln is log base e. Right? So that will be the base first, right? Okay, never mind. I tell you what. We write log base e first. Then we convert it later to ln. Okay? Right, so we have the base first, the log with the base, and then 3, and then your index here, this is your index, right, will become your answer on the right hand side. Okay? And we change this log base e to the correct symbol, which is ln. So basically, this is how we can convert from one index form to a logarithmic form. All right, let's do another example. Let's say we have, what do you want? Quick, tell me. 2 to the power of x equals to 8, let's say. Okay, right. So the base will be base 2. So we will have log base 2, right? Okay. And then the answer on the right hand side will become the left hand side. And the index will have to appear on the right hand side. Okay, so this is how you can convert from index to log. So, but what happens if I want to convert log to index? It's also not difficult. Let's try to do one question. Let's say I have log. Okay, let's say I have LG. Okay, LGX equals to 4. Right, then you must remember LG is log base 10. Okay, so LG it's log base 10. So we use log, change it to log base 10. Okay, always start off by recognizing the base. You need the base. The base is very important. The base provide you the foundation, provide you the support. So look out for the base first. So in this case here, the base is base 10. So that will be 10 to the power. This guy here become your index. And what is on the left become on the right. Okay, so this is how we can convert from index form to logarithmic form and vice versa. And this is an important concept. Right, so the next thing very important is we need to recognize the logarithmic curves. All right. So for a logarithmic function, log base ax. All right, let's repeat. The base cannot be equals to 1. The base can be more than 0. So basically, the base can be more than 0, but just not equals to 1. So it can be 0 0.1, 0 0.2, 0 0.4, up to 0 0.99999, but cannot be 1, right? Then after that, can continue from 1.1, 1.2, so on and so forth. This is what it means. Okay, and then x more than 0, right? So the first curve will look like this. Your a can be more than 1. So we need to explain how do we get this value here. Right, actually it's not difficult. Why is it not difficult? If you're going to let log base a, right, you're going to substitute your x to be 1. Okay, this is what we get, right? We're going to find the y coordinates, huh? Right, so this is your logarithmic form. So in the previous slide, we already learned how to convert from logarithmic to index form, right? So we're going to do it now. So let's look out for the base. The base is base a. So a to the power y is equals to 1. And 1, if you were to recall, much earlier on, we also have gone through the rules of indices. And one of them is a to the power of 0 is equals to 1, right? Like 2 to the power of 0 is equals to 1, 3 to the power of 0 equals to 1, 4 to the power of 0 equals to 1, so on and so forth. So if you compare these two fella, can you see that y is equals to 0? Let's explain how we get this value here. Okay? Right. So what happens if your values of a is more than 0 but less than 1? Remember, a more than 0 means it can be 0 0.1, 0 0.2, 0 0.3, 0 0.999, but it just cannot be 1. Okay, and then it can go on to be 1.1, 1.2, 1.3. So there's actually two range of values of a. One is practically more than 1, and one is more than 0 but less than 1. So if your values of a, which is the base, is more than 0, less than 1, then your curve will look this way. So these are the two basic shapes that you have to remember. Right. So the next thing that we need to understand on solving logarithmic functions is the logarithmic laws. Okay. You have to memorize the laws because it won't be given to you in the formula sheets in the exam. Right. So basically, there are just 3 laws you need to remember. Okay. First of all, your a, x, y must be positive numbers and a not equals to 1. Power law. What is power law? All right. Power law basically is that if you see that r is actually the power or the index or the exponential, right? So you can actually just bring it to the front. Okay, just bring it to the front, end up like this. That's called the power law. Product law and the quotient law. Okay, so these 3 laws very important, you have to remember. Okay, I'm going to show you some some kind of misconceptions that some students may make when they apply these laws. So you need to understand the laws correctly, otherwise you'll make mistake. So what are some of the misconceptions, common mistake made? Right. So if you look at it very carefully, your power belongs to the y only. Okay, it does not belong to x, y, it just belong to the y only. Okay, so you can't apply power law here. Okay, can you see the thing not equal? You cannot apply power law. You can only do it if you have log base a bracket xy bracket to the power of r, then you can apply power law here. Okay, otherwise you can't. So that's common mistake number 1. Common mistake number 2 is right. Can you see the mistake here? Yes, this operation has to be plus 2 log plus together. Okay, will gives you 1 single log. 2 logs, you start off with 2 log, right? 2 logs, same base, must be same base, huh? Same base, base A. Middle operation is plus, you can combine to 1 single log and then become x times y. Okay, so mistake number 2 is this is wrong, huh? It cannot be times, okay, it has to be plus. Okay, mistake number 3, likewise, can you see? If you look at your quotient law, it's from 1 single log, okay, bracket x divided by y to become 2 separate log. Okay, 1 single log to become 2 separate log. So what we have here is 2 logs here. So definitely you can't apply quotient law here. Okay, so please take note of these common mistakes and don't make them. Okay, learn the law correctly. Okay, so let's look at this question now. It may appear to be kind of scary, but actually it is not. Why is it not? Because if you were to examine the base, they are all having base A. Right, so basically you just have to apply the laws correctly. Alright, so let's look at the first 3 terms. You have log plus another log plus another log. So which law would have log plus log? Correct, your product law. So we can apply the product law here. So the product law, basically you just multiply 2y squared times 8 times 16y, make it into a single log. And then the one that's highlighted in yellow, which law do you think you can apply? Yes, very good. Power law. Okay, the power law. So how do you apply the power law? Just look at the coefficients, which is 2, bring it up. Okay, become the power of 4. Right. Okay, then the next thing is, look at what we have on the screen. Which law can we apply when you have log, then minus another log? Yes, I can simplify 4 squared as 16. Right, so the one highlighted in The nice blue, yes, we can use the quotient law. All right, so you see that I have log base A on the left, log base A on the right. So basically, I can just do and just say, okay, since log base A is equals to log base A, so therefore this guy here must be equals to this. They must be equal, right? Okay, and of course you can simplify 256y cubed divide by 64y to get 4y squared. All right, so the next thing is 4y squared is equals to 16. Y squared is equals to 16 divided by 4 gives you 4. So your y can be positive 2 or negative 2. Right, so the questions I'd like you to ponder on is why is y equals to negative 2 being rejected? It's because it is because it's a negative value. Is it because all negative values have to be rejected? Right, so I need you to think about it, okay? Because I'll give you a hint. It got to do with the conditions of how your log base ay is defined. Okay, got to do with how this is being defined. All right, now let's look at example 4. Right, I've chosen these questions for you because it involves some special skill. Right, special skills such as using the substitution method. The substitution method is a very versatile method that you can actually use it every now and then to solve problem sums. And of course, in these questions, we also need to apply some special log. So what are the special log that we're talking about? All right, so what this means is that if you have a log, this one, it means that if you have log base 2 basically it just equals to 1. Or if you have LG 10, because LG is log base 10, it just equals to 1. It's quite easy to prove. How do you prove it? You just let log base a equals to x. So I want to find the values x. So I'm going to convert this logarithmic equations into index form. So your base is a, so a to the power of x is equals to a, and basically a is just a to the power of 1. So can you see that x is equals to 1, right? So this is very useful. This one's very useful, and this one we have already proved it in the earlier slides. Okay, so these are the two very important special log that we need to take note, and some important special skills. What are they? Yes, for example, if you are given the number 3 and if you want to express it in terms of log, you can actually write it this way, because log base a is 1 right here. Log base a is 1. So basically 3 is just 3 times 1, right? And then you can apply the power law. You can bring the 3 up to become the power of a, right? Another example is, let's say if you have you can actually write it, yeah. So basically it's just to express whatever number you're given in terms of log to help you solve the logarithmic equation. Okay, and of course the substitution method that I mentioned just now, which is very important. All right, so let's look at how we solve this question. So first of all, 27 is 3 to the power 3. Why I want to write 27 as 3 to the power 3? Because if you were to examine the questions, they're all expressed in base 3. Okay, so I'm going to write 27 as 3 to the power 3, and let's see what happens. All right, so this here I can apply the power law. Okay, here I can apply the power law. So basically you just bring it to the front, become the coefficients, and log 3 base 3. Remember the special log that we talked about is equals to 1, right? Log 3 base 3 is equals to 1. Okay, so here comes the substitution part. We're going to replace, yes, let log base 3a to be the letter B. You can let any other letter, but just don't let it be letter A. Okay, unless you want to use uppercase A, otherwise use other alphabets. Okay, right, so that will gives you 3 times 1 over b equals to b minus 2, and that gives you a simple algebraic equation where you can just multiply both sides by the letter b. You can just term b throughout. So that will gives you 3 equals to b squared minus 2b, and then you simplify it to be a quadratic equation, factorize it. Right, so you get b equals to 3 or b equals to negative 1. Alright, so basically the value of b is not what you are finding. The values of b is a substituted value for log a base 3. So you're finding the value for a, not for b. So you need to let log a base 3 equals to 3, then convert it into index form. If you have forgotten how to do it, go back to the previous slides. So that will be 3 to the power of 3 gives you 27 for the first values of a. Second value will be 3 to the power negative 1, which is 1/3. Okay. Alright, so besides knowing all the 3 basic laws, the product law, power law, quotient law, you also need to know how to change the base, because your calculator only has, in your O-level syllabus, the calculator that you are allowed to use by the SAB standard, it's 1 with base 10. Okay, you can't use the 1 with other bases, so we need to know how to change base. For example, if you're given base 2, how do you change it to base 10 so they can use a calculator to evaluate the answer? Alright, so this is what we're going to do now. Concepts needed number 3, change of base, which is relatively easy. Okay, we're going to do some examples how we can actually apply the change of base. So let's look at the special case. So if you have log 2 base 3, basically is if you want to change it to base 2, it's just 1 over log 2 base 3. Let's have another example. Let's say if you have let's say I'm looking at this. Let's say if you have log 4 5, right, actually that is equals to 1 over log base 5 4. It's just the reverse. The reverse, the base, it just switch these two position, 4 and 5, switch the position, but make sure you need to have 1 over. Okay, let's do another example. Let's say if you have log base a c, we switch the position, but 1 over first, 1 over, then we switch the position. There'll be log base c then a. Okay, it's quite easy. Right, let's do another example. Apply this one here. Okay, example 5. So you're supposed to solve this equation. So if you were to look at it carefully, you see that this one is base y, whereas this is base 3. So they're not compatible. You see, they're not compatible. Right, so we need to change it such that they have the same base. Right, so do not change it. Do not change base 3 to base y. It's much more complicated. Right, it's much more complicated. It's easier to change base y to base 3. Okay, if you don't believe it, you just try it out on your own. Okay, really, you must try things on your own, then you realize what I'm talking. Alright, so here I'm just going to change base y to base 3. Right, so how do I apply it? Correct. Okay, so I'm just applying this one here. That means you switch the position. Okay, y become 3, 3 become y, and then 1 over. Very important. Alright, so come up to these steps here. Alright, that is where we need to apply the substitution skill again. Okay, substitution skill. So we're going to let log y base 3 to be a letter a. So you have 5 minus 6 over a equals to a. Multiply both sides by a, you get 5a equals 5a minus 6 equals to a squared, you end up getting a quadratic equations where you can factorize it. And then you can find the values of a, which is 3 or 2. Let me erase this part here. Yeah. Okay, right. But a is a substituted values again. The original values we need to find is y, not a. Right, so again, after you get your logarithmic equation, apply the skill to change it to index form. Start off by looking out for the base, which is base 3 here. So 3 to the power of 3 equals to y. That will be 27 for the first value of y. Second value will be 9. Okay, so this is how you solve questions involving change of base. Alright, so here comes to example 6, and example 6 is actually question 3 of your homework that you're supposed to do. So if you have problem doing question 3, just look at my solutions. Alright, if I'm not wrong, I think this is an O-level questions, okay? But it's not difficult. Why not difficult? Because basically you can just apply the power law for this. So you can just apply the power law, right? And this, you can apply the quotient law. So there are two laws you can use here already. That will give you one or two marks already. Okay, take note. Take note. It's very important that you bracket x square root y. This is very, very important because the power 4 belongs to the whole thing. Okay? Power 4 belongs to the whole thing. So make sure you bracket it. Say it 3 times. Yeah, okay. Don't be so naggy. Right. Then the next thing is apply the power law. Quotient law, sorry, quotient law. Alright. Okay, so what's this next step? Yes, remember the special skill that we learned earlier in the earlier slide. Okay, we need to write 1.5 as 1.5 times log 10 because log 10 LG is base 10, so log 10 is 1, right? Basically this guy is equals to 1. So it's just 1.5 times 1. Okay, and then you apply the power law. Okay, I will explain to you why I want to change it to LG. But I think you know the reason. So that I can apply the product law. Yes, you are right. So that I can apply the product law. See? So if I change my 1.5 in terms of log something, can you see I have a log here and another log here, and this is plus? I can just apply your product law. Yes. Yes, by applying the product law. Very good. So I have log on both sides, which means whatever it's inside here has to be equal to whatever that's here, right? It has to be equal. Correct? Okay, yes, very correct. I'm sure. Okay, now let's continue. I think the just now was I thought that I have just clicked stop recording before I finish it, but I forgot actually the solutions are too long, so I need to escalate it into a new slide. Is it called escalate? No lah, continue in the new slide. Oh my god. Okay, I need to continue in the new slide. So we have just agreed that whatever is inside here is equals to whatever that is inside here. They are equal to each other. So that's the next step. Okay, so we need to simplify it. Right. So maybe I explain to you how I from here to here. So it's just this one means y to the power half, right? And then the whole thing to the power 4, right? So x means x to the power 1, right? So 1 times 4 will give you 4 here. Half times 4 will give you 2. Right. That's why we're just applying this law. So some of you may find A math much more difficult than E math because there's so many laws and rules to remember. So consistency is very important, okay? It's not something that you can do last minute because there's so many things to memorize, right? So please do practice consistently. Okay, and then we can do a shortcut cross multiply. I need to make y the subject, so basically I just need to group all my x together. Okay, and then this one here, you can simplify further. This can simplify further. That will give you x to the power of 4 minus 1. That gives you x to the power of 3. Just plain this value here. So you need to cube root it because you have to make y the subject. Right, so to cube root it, I think it's advisable to rewrite 1.5 as 3 over 2. So let me see why. Let me explain to you why. Okay, cube root it means to the power of 1/3. Cube root x means x to the power of 1/3. Okay, right. So we can write your answer as y equals to square root 10 over x. And for some atas paper, you want to write it as y equals to square root 10 x to the power of -1. Go ahead. Okay. If not, just y equals to 10 to the power half over x will be fine. Alright, example 7 is actually question 4 of your homework questions, and these questions we need to use a substitution method. Right, so we're going to substitute log y base 2 to be u. Right, so we need to work on this first. Work on this. Because this expression is base 8. So we need to apply change of base to change it to base 2. Right. Okay. Right. So to change it to base 2, you need, if you were to recall change of base, first of all, have a horizontal line, you become a fraction. So whatever base you want to change to lah. Let's say I want to change to base e. Then write like that first. Log base e on top, write base e below. And then your original base, which is a here, will go to the bottom. Right. And then your b will go to the top. Original base a go to the bottom. So this is how you do the change of base, right? So you see that original base 8 will end up as the denominator. Okay, and then the next thing is your 8 can be expressed as 2 to the power 3, so that I can apply the power law. Right, I can apply the power law. This 3 can bring it down to the front to get here, and log 2 base 2 basically is 1. Right. And then I can just substitute your log y base 2 as u. You get 3 over u equals to 2 minus u over 3. Multiply by u on both sides. And then multiply by 3 on both sides again. That means do it slowly lah. But if you don't want to do it slowly, then you just one shot multiply by 3u on both sides. But usually I prefer to like times u's first. And then times 3. Okay, to get a quadratic equation, factorize it. And you get u equals to 3. So repeated roots. So u is the substituted values for log y base 2. Okay, you need to erase all this. Erase, 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 erase. Very, very messy. Alright, so u is equals to 3. And then when u is equals to 3 means log y base 2 is equals to 3. Okay, convert it into index notation. Index form, not index notation, index form. So y is equals to 2 to the power of 3 equals to 8. That's how you solve this question 4 or example 7. Right, now let's look at example 8, which is question 7. Okay, so another popular kind of O-level questions involving logarithmic functions. Okay, so in this case here, you have an object, you put in the oven and then you heat it up until it reaches a certain temperature. So it could be 68 degrees Celsius or 98 degrees Celsius. Heat it until it's hot lah. I don't have an oven. Oh dear, I do have an oven. Yes, you can heat it until 120 degrees or 180 degrees Celsius. Yeah, okay. And then after that, you put it on the table to cool because it may be too hot to eat it, lor. Right. And so the equations are given. Okay, this represent how long it takes for your object, could be a chicken, cakes, salmon, whatever lah. The time taken for your object to cool it so you can eat it. Right, and then this will record the temperature. Right, so you ask to find the values of x. So as explained for you there, x degrees Celsius is the initial temperature of the object after it has been heated. Right, so it could be that just now I mentioned, I think if you're cooking salmon, I think you have to put the temperature to 180 degrees Celsius, cook it for 20 minutes. Right, but in this case here, you substitute T to be 0. Oh, so the X is 80 degrees Celsius only. What kind of things you just heat it to 80 degrees Celsius? Oatmeal or something like that, maybe milk or what. Okay, so basically X is just the initial temperature of the object after it is heated in the oven. That means you just take it out from the oven, no? That is when the T is 0. Okay, right, so part 2. So you leave it on the table for 16 minutes, and what do you think will be the new temperature? So basically you just substitute T to be 16 and use your calculator to work out the answer. Okay, use your calculator to work out the answer, and you work out to be 26.4 degrees Celsius. Right, that means 16 minutes later, okay, from 80 degrees Celsius you drop to 26.4. I think you can eat it already. Okay, all right, so the last question usually is a more difficult one. Part A, part A, part 2 usually are the ones that just let you score some points. Okay, part B is the one that you need more steps. So part B is the one that say that, for example, I want how long do you think you will take for it, for the temperature to drop to 48? Okay, how long do you think you will take? Right, so you need to substitute theta to be 48. Okay, and then you will get. All right, so here it appears to be easy, but there is one very common mistake a lot of students make. So I need to remind you. You substitute theta to be 48, you end up getting this equation, right? Okay, please do not bring ln here. Some students will do this, ln. You find that here, ln 48, you can easily use a calculator to evaluate, but you have a huge problem on the left hand side. There's no loss for it. You only have log A plus log B product law, right? Or log A minus log B. You don't have log bracket something plus something. There's no such law one. There's no such a law. So you're at handicap here. Okay? So therefore you cannot bring ln straight away. What you need to do is to simplify it, minus 18 on both sides, and then divide by 62. Basically, you can only bring ln only when you are left with the exponential functions on the left hand side. Only left with e to the power of something. Okay, only left with e to the power of something. Then you can bring ln. Can you see? Right, here you can use a power law. Okay, and ln e is 1. Why is ln e 1? Because ln is log base e, so log base e is 1. Okay, so you end up getting t to be 5.81 minutes. That means the total time taken for your object to reach 48 degrees Celsius, it's 5.81 meters. Right, so when t becomes very large, basically means t could be like maybe 60 minutes later or 1 day later or 3 weeks later, then you will see that this value will become very small. So small such that it will tends to be 0, but it will not become 0, it just tends to be 0. So that even if you multiply with the number 62, right, the number itself will still be very small, near to 0. So you have 18 plus something that is very, very small. Okay, and therefore it will, the final answer will just be 18 itself lah. That's what it's saying. And then the temperature will not go any further, so that will be the room temperature lah. Okay, yeah, this is what the questions it's asking about. All right, let's come to the almost to the end of the video. I'm going to present to you a different kind of question. So far what we have been doing are solving logarithmic equation, right? You may be asked to solve questions like this. Okay, given that y equals to log x base 4, find in terms of y. So if you look at it, they are actually not logarithmic equation. Can you see? It's not a logarithmic equation. It's not something equal to something. Right, you just need to replace this, find the value of this in terms of y. So this is what I mean by a different kind of questions. Okay, but the concepts applied here is still the same. When I say concepts, what do I mean? It's basically still the same logarithmic law, product law, power law, quotient law, and also all the change of base, and all the special law and all the special skill that you need to use, okay, still apply to this question. It's just that this question is different from what we have done previously. So how do we go about doing it? If you look at part A, right, we can just split it into 2 logs. The product law is from 2 log to become 1. We can also use from 1 log split into 2 log. So here you can see that I can split 32x squared into log 32 base 4 plus log x squared base 4. Okay, the reasons why I want to do that is so that I can apply the power law here, so that I can use this. Okay, I can replace log x base 4 with values y, which is what the questions want us to do lah. Find in terms of y, find the values in terms of y. Okay, and then here I would have to change it to base 2. It's easier because 2 to the power of 5 gives you 32. So it's easier to change it to base 2. And 4 is 2 to the power of 2. Okay, rather than struggling with a base 4, like 32 is 4 to the power, blah, 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 give you 32. You can still do it, but in the end, I think it's easier to just change it to base 2. We can still do it. How to do it? Let me show you. You can just let log base 4 32 equals to the value x, right? And then change it to indexed form. It's like solving an exponential equation really, right? But you still have to express 4 as 2 to the power of 2, 32 as 2 to the power of 5, and then 2x is equals to 5. This is solving exponential equation really. And so x is 2.5. That means log base 4 to the power of 2.5 will gives you log base 4 32. That means 4 to the power of 2.5 gives you 32. Right. So rather than having to go through this huge process here to find that, just basically change your log base 4 to log base 2 easier lah. Okay. Right. And then this one here, I can apply the power law. I can bring the 2 to the front to get what I have here. Then the next step is 32. You can write it as 2 to the power of 5. 4 is 2 to the power of 2. Apply power law again. Right, and this one here, replace it with the letter y. You get 2y, and log 2 base 2 is 1. This will end up 1, this will end up 1. So your answer will be 5 over 2 plus 2y. Okay, so that's how we do part A. All right, let's do part B. Okay, so we can apply the quotient law. So you just work backwards. Quotient law is log x minus log y gives you log bracket x over y, right? So if you work backwards, that means from a single log, you can just use quotient law to break it into two logs. Okay, and 64, you can write it as 4 to the power of 3. Oh, you need to change base, sorry, because this one, what you're given here is log base 4. So you need to change it to base 4. And this one, of course, is our special log. Log 1 base x is 0. Okay, let's continue. Then 64 is 4 to the power of 3. Okay, so apply power law again here. Right, so log 4 base 4 is 1. So basically, you get negative 3 over y. Okay, I think I erase this part here. Okay, so that's how you do this different kind of questions. Right, so we've come to the end of the video. Right, the questions, the practice questions, and all the concepts we've covered in this video are sufficient for you, right, to solve any problem sums in your tests or exams. However, if you want more practice questions, so please click on the link below. All right, thank you very much.